Hello, good evening. This is Naz from NB Network Lessons. Hope everyone's doing okay and in high spirits. My today's topic of discussion is Advanced Calculus lesson number 73, and we're going to solve another sequence example. I've been solving sequence examples in last couple of lectures, but today we're going to go ahead and solve this problem and close this section. But before I do that, I would like for you to please read this theorem. Basically what this theorem says, that if you have a sequence, right, and the limit is going to infinity, if you take the absolute of that sequence and if it's 0, then the non-absolute sequence is also 0. I'll show you that by an example. But before I get started, I just want to make sure that everyone understands what absolute numbers are and how we calculate the absolute values. So this is just a recap, quick revision. Let's say you have y-axis and you have x-axis, right? So this is your x-axis and this right here is your y-axis. So let's say you have 1, 2, 3, 4. 1, 2, 3, 4. And then you have -1, -2, -3, -4. And let's say I give you a number 4 and I ask you to find the absolute value of 4. So the way you represent absolute value is you put 2 bars and in between you put the number 4. This is the absolute value. Absolute value is basically the number of units away from origin. If 4 is right here, how many units is it away from the origin? This right here is the origin. So then it's 1, 2, 3, 4. So the absolute value of this 4, positive 4, is going to be 4. Now let me ask you this. What if I asked you to find absolute value of -4? What would that be? Well, it's the same thing. It should be positive 4. Why? Because we are not looking at negative or positive. What we are looking is the number of units away from the origin. So in this case also, the number of units it's away from origin is 1, 2, 3, and 4. So then the absolute of positive 4 is 4. Absolute of -4 is also 4. Okay, I just wanted to recap that before we dive into the problem. So this is the problem on the board right here. You have a limit n going to infinity, and then you have -1 raised to the power n, and then you have n squared over 1 plus n3. In the past, we've been solving problems, sequence problems, where everything was positive. But in this case, we have a -1. So what do? What we do is that we keep this theorem in mind and we say we take the absolute of this. All right. So then what I do is that I say a n, the sequence number, and I take the absolute of that. When I take absolute, limit n going to infinity, when I take absolute of this -1 becomes plus. So 1 raised to power n is 1. So then we can write this down as n squared over 1 plus n3. You see how I got rid of this? I got rid of this by making it absolute. When I do the absolute, this is basically becomes +1. Now what we got to do is we got to put the value of infinity in here. When I do that, I get infinity over infinity. Right away I know that I got to apply L Hopital's rule to find the answer, because this is infinity of infinity. So what I do, I take first derivative of numerator, first derivative of denominator. So let's go ahead and do that. Limit n goes to infinity, derivative of n squared is 2n, derivative of 1 plus n cube is 3n square. Let's go ahead and put the value of n in here. When I do that, I still get infinity over infinity. That's no good. I was not expecting that. Well, no worries. What we're going to do is we're going to take another derivative. So let's do that. Limit n goes to infinity. All right, I take derivative of 2n, I get 2. I take derivative of 3n raised to the power 2, I get 6n. So let's go ahead and plug in the value of n, which is right here, infinity. So then I get 2 over infinity, which is equal to 0. What does the theorem say? Theorem says if the limit of n approaching infinity of an absolute sequence an value is 0, then limit of n approaching infinity of the regular sequence non-absolute is also 0. So guys, that's all I wanted to touch base on today. I just wanted to show you. I'm going to go ahead and close the sequence section now in advanced calculus and come up with a new topic. Stay tuned. Thank you so much for watching. If you like the contents, please go ahead and share and give me a like. Thank you.